TRELLIS.2 is a state-of-the-art large 3D generative model with 4 billion parameters that can turn a single image into a fully textured 3D asset. It introduces a new field-free sparse voxel representation called OVoxel that lets the model build and produce complex shapes with open surfaces, non-manifold geometry, and internal structures while keeping the model small and fast. The system uses a sparse 3D and a diffusion transformer to learn a compact latent space and generate high-resolution assets with realistic base color, roughness, metallic, and opacity maps that support transparency. Key features include 1. High quality and efficient generation with 4B parameters. The model can output 512 cubed, 1024 cubed, or 1536 cubed assets in about 3, 17, or 60 seconds respectively on an NVIDIA H100. The process first compresses the shape into a 16 times downsampled latent generation, then runs in a single forward pass of a vanilla diffusion transformer. 2. Handles arbitrary topology. OVoxel removes the need for assigned distance field. It directly stores sparse voxel geometry and surface attributes, allowing the model to generate open surfaces such as clothing or leaves, handle non-manifold geometry like sharp edges, and keep enclosed volumes intact. 3. Rich texture modeling. Beyond simple color, the model learns separate channels for roughness, metallic, and opacity, producing materials that can be rendered with physicality-based shading and transparency. 4. Minimal processing pipeline. The conversion from a textured mesh to an OVoxel block takes under 10 seconds on a single CPU core, and from an OVoxel back to a mesh it takes under 100 milliseconds on CUDA. No rendering or optimization steps are required, making the pipeline practical for real-time applications. The roadmap for the project lists key hires, paper release, inference code and pre-trained checkpoints, a Hugging Face demo space, a texture generation inference script, and full training code. Installation requires a Linux system, an NVIDIA GPU with at least 24 GB memory, and Python 3.8 or newer. Conda is recommended for dependency management. After cloning the repository, run a setup script that optionally creates a fresh environment and installs optional components such as Flash Attention, NVDifrost, and the OVoxel library. The commands look like git clone, recursive HTTPS, GitHub Microsoft TRELLIS.2, git cd TRELLIS.2 source conda sh.setup sh, new env, basic, flash at, NVDifrost, NVDifric, qmesh, OVoxel, FlexGem. The pre-trained weights, called TRELLIS.24b, are hosted on Hugging Face. After downloading, you can load the pipeline with a single line of code. TRELLIS.2 image to 3D pipeline from pre-trained Microsoft TRELLIS.2-4b. You then pass a pillow image to the run method to receive a mesh object. Once the mesh is obtained, you can simplify it, render a preview video, or export the geometry to the GLB format for use in game engines or 3D software. Exporting in GLB yields opaque rendering by default. To enable transparency, you simply connect the alpha channel of the texture to the material's opacity input in your preferred 3D viewer. A web demo is also available. Running Python AppPy starts a lightweight server, and you can upload an image from the browser to instantly see the generated 3D asset online. For texture generation, a separate pipeline generates PBR textures given a shape. The accompanying example script shows how to load a shape, generate textures, and export a textured mesh. The full training code is publicly available. The first step of training is to convert every raw 3D asset into the OVoxel format, which the repository's data toolkit can accomplish. Once the data is ready, the TrainPy script drives reinforcement of the different parts of the model, including the shape SCVAE, the texture SCVAE, and several flow models that learn how to convert image features into shape and texture latents. The training scripts accept a wide range of command line options for configuration, including data paths, checkpoints, and distributed training settings. Some of the specialized libraries that TRELLIS.2 depends on are OVoxel, the core library that converts between meshes, and the sparse voxel representation FlexGEMM, a fast sparse convolution implementation that scales well on modern GPUs. qmesh accelerates mesh post-processing tasks such as remeshing, decimation, and UV unwrapping. The project is released under the MIT license, but some optional dependencies such as NVDifrost and NVDifric are governed by their own permissive licenses. If you use TRELLIS.2 in your research or products, please cite the following article: Xiang, Jianfeng, Chen, Xiaoxu, Shu, Sichen, Wang, Rucheng, LV, Zelen, Deng, Yu, Ju, Hongyan, Duang, Yu, Zhao, Hao, Yuan, Nicholas Jing, Yang, Jialong, Native and Compact Structured Latents for 3D Generation Tech Report, 2025. This completes the introduction to Trellis.2 and provides the most important information for anyone who wants to try or extend it.